So today we're going to look at fractional equations. And if you're looking at the note sheet like you should be, you'll see a bunch of different stuff on the top of our note sheet before we get to the examples. Let's explain what that is first. First, it says let f of x and g of x represent algebraic expressions. Then the solution of the equation f of x divided by g of x is equal to 0 are all the values of x such that f of x equals 0 and g of x does not equal 0. So what does this mean in plainer English? Okay. What this is saying is that if you have a fractional equation, you want to make sure that the top equals 0, but the bottom x values cannot equal 0. Because if you have a 0 on the bottom, you have an undefined fraction, which is no good in math. Okay, so what we're going to be doing is taking the top, setting it equal to 0, and making sure that those same values don't make the bottom equal to 0. Okay, so on the bottom it says, in other words, a solution to the equation f of x over g of x equals 0 is an x value that makes the numerator, so the top of our fraction, equal to 0, and does not make the denominator or the bottom of your fraction equal to 0. All right, so let's get into this and show you some examples of how this works. All right, so here's our first example. You have x squared minus 2x plus 1, and then on the top in your numerator, and then x minus 2 on the bottom. Okay, so what we're going to have to do for this problem is we have to factor the numerator. So step one, you're going to factor. So sometimes it might be the top, sometimes it might be the bottom of your fraction, sometimes it might be both. In this case, it's the top. So you're trying to find out two numbers that multiply to give you positive 1 and add up to give you negative 2. All right, those factors are negative 1 and negative 1. All right, next what you're going to do is the way we get to be x values that equal 0 on the top but don't equal 0 on the bottom is if we have something that's in common between the numerator and the denominator, we cross it out, which gets us to step 2. So we're going to cross out common factors. In this case, there is no common factors. X minus 2 does not match either x minus 1 or the other x minus 1. So there's no crossing out to do. So then what we're going to do is solve the remaining numerators. Well, x minus 1 and x minus 1 are the same thing. So you only have to take one of them and solve for it. So you're going to take x minus 1 as a factor, set it equal to 0, and then you're going to solve for x. So x will equal 1. And then you're done. And that is it. Okay. In the next example, we'll see how it's a little more complicated. And complicated just because there's other things to do inside with crossing out things. Okay, so step 1 still is factor the problems. Okay, so we have a quadratic on the top of our fraction in the numerator and a quadratic in the bottom in the denominator. So if we factor them both, on the top we're looking for something that multiplies to negative 2 and adds up to negative 1. On the bottom we're looking for something that multiplies to 5 and adds up to 6. So your factors should be this: x minus 2 and x plus 1 at the top, and x plus 5 and x plus 1 at the bottom. Okay, and here's where the complication comes in. If you solve just the numerators and you get x is equal to negative 1 on the top, that also makes the bottom 0, because x plus 1 and x plus 1 are the same thing. Well, you can't have a denominator have the 0 in it, because that would be an undefined fraction, so that's bad. So this is where we cross things out. So you're going to cross out common factors. So the x minus 1 that you could have found with that numerator actually can't be an answer. It is, again, it makes the fraction undefined, which is not good. So we cross the things that are the same out, because those can't be solutions. Then we go to step 3, which is solve the remaining numerators. We only have one remaining numerator, the x minus 2. So we set that equal to 0, and then solve for x. So x will equal 2. Now, you might be asking yourself, what about the denominators? You don't have to solve them. You're just trying to make sure that there's nothing that can cancel out with a numerator. So after you factor it and see if there's anything to cross out, you're done with the denominators. You don't have to use those again to solve these problems. Okay. Next, here we go. So we've looked at two examples. There's two more. Try this one on your own. Pause the video, factor the two quadratics, cancel something out, then solve the numerator. So go ahead and do this one, pause the video, and then come back. So hopefully you pause the video. When you factor these things, you can do factor by grouping. You can do the bottoms up method, I'm pretty sure we looked at. All right. Factoring quadratics are all over this whole unit. So if you're not sure about how to factor quadratics, you might want to go back to the very beginning of this unit and kind of catch up with that, you can always go back into the previous weekly agendas to find the solving quadratic videos. All right, so when you factor these, you're going to end up with this. So you have 2x minus 3 and x minus 2 on the top in your numerator. You have 3x plus 1 and x minus 2 in your denominator. Okay, as you can see, we're going to cross out the common factors of x minus 2. And then whatever's left over, that's what you're going to solve your remaining numerators. So you have 2x minus 3, set it equal to 0, and solve for x. So you're going to add 3 and divide by 2, which gives you 3 over 2. And that is your answer. All right, there's one more. Again, please pause the video, try this one on your own, see what you come up with, and then check back with the video to see if you got it right. All right, so hopefully you paused it, you're back, you're ready to check your answers. So the first thing, again, we're going to do is factor. So if you factor these two quadratics, you'll end up with these factorizations, 3x plus 1 and 2x minus 1 on the top in the numerator, and then 2x minus 1 and x plus 5 on the bottom in the denominator. All right, we're going to cross off the common factors. So the 2x minus 1s can both be eliminated. And then we solve the remaining numerators. The only remaining numerator is the 3x plus 1. So we set that equal to 0, and we solve for x. So you get negative 1/3. All right, and that is solving fractional equations. That is it. This unit is over, and now it's on to review. Good luck.